Okay, so in the previous lecture, we talked about undamped behavior, and before that, we talked about femboy acting as a spring, or behavior of a femboy acting as a spring. So in today's video, we're going to be talking about behavioral resonance. So if you have your textbooks, which you already know the drill, turn your pages to 169 or turn your books to page 169, section 10.3, resonance. So in the previous lecture, we talked about the type of the differential equation x double dot uh, plus beta squared x dot equals some function f of t. Or actually, it's x double dot plus beta squared x dot plus gamma x equals f of t, where f of t is some force that keeps the spring from that that lets the spring continue to propagate, right, after it's assumed to have reached equilibrium. So in the same vein, we can think of f of t as sort of a force or a thing that we do on the femboid that lets him continue deciding, or the gender fluid person. We do something to that gender fluid person to let him or her or them continue identifying back and forth between a male and a female. So we talked about in the previous lecture. And the previous lecture we were talking about undamped behavior wherein it's mostly there is no setbacks or there are no obstacles when it comes to deciding, and that the deciding will continue to propagate and not decay over time. And so now we're gonna consider the case wherein, right, let's say we have a decision. I think it's a different pen. You got decision interval like this, and then it's gonna repeat again. So that's a period. So this is the period P, and then the period P repeats, and then on and on. This is what we call resonance. You probably know the term resonance. You can probably know where I'm coming from. The one by Home, the synthwave track Home, the popular one, the one that people mostly think about when I say the word synthwave. People will think resonance by Home, and that's sort of we can sort of connect that video to this video, or we can connect that music video to this video by saying that yes, when you hear the track or you listen to it really carefully, there actually is a resonance or a continuation or echo of the tracks, which is why it was called or named resonance, or probably why it was renamed resonance, because the the initial sound resonates. So in the same vein, if we have some decisions over a certain time interval, and then those decisions are repeated, but maybe somewhat different, like an echo, we call that behavioral resonance. And it is modeled by this function, x double dot of t, or just x double dot, plus beta squared x dot, or just x of t equals a sine beta t, wherein beta squared is equal to kg over w. But just don't find the beta squared, the beta term, because we're defining the trap or the femboid we're talking about in these lectures is actually under the standard quantum trap configuration, which tells us that its mass and its energy is 1. Like I said, it's highly idealized. This course is very idealized because we're mostly focusing on the mathematics and the physics here rather than actually applying it in real life. This is more of an abstract topic. It's like high school physics, as I said from the beginning of this course. We're in A and beta are constants, right? These are constants. And you can already tell sine, it's a wave. It's a wave. You already know it's a wave. It goes back and forth. It's a propagation, right? And so it repeats. So complementary function of this differential equation is x sub b, complementary function is x sub b equals p sine beta t plus q t cosine beta t. We're in q, p, and beta are constants. So p, beta, and q constants. That's our complementary function. So this is determined using the law of on the method of undetermined coefficient. This is actually the particular solution and not complementary function. Um, yeah. So P and Q are constants to be determined. So if we directly substitute this into our initial differential equation, no, you guys can see that. Okay, if we input this over here into the previous differential equation, we get something like this. Step 2 p beta cosine beta t via the chain rule minus 2q beta sine beta t equals a sine beta t. We get this, and then this equation can be satisfied for all t only if p is 0 and q is equal to negative a over 2b. So therefore, we can change this equation into x sub b equals minus at over 2 beta cosine beta t. And now we can, using this and the previous thing that I wrote, we can now construct a general solution for our differential equation that models resonance or behavior that repeats or echoes. And that general solution, using all these things that I just wrote, would be x is equal to c sub 1 beta cosine beta t minus c sub 2 beta sine beta t minus plus a times over the at over 2 times beta t minus a t over 2 beta cosine beta t. And this entire mess of mathematical symbols are actually very organized if you have the eyes of a mathematician. This tells us, or it gives us, the graph of the behavior interval of a specimen or a gender fluid person whose gender fluctuates up and down, and it echoes after a certain period or after a certain time. So it echoes, and then it stops for a while, and it goes again. But this time it's slightly smaller, slightly smaller. So eventually, at some point, with all this echoing, it's gonna diverge at 0. So notice how if we take the limit of x as t approaches infinity, this all vanishes to 0. So the more we travel along this graph, the closer we get to 0. So at some point, our specimen stops identifying. It's like damp behavior. Even though we have a term or a force that lets the femboid or the trap continue to fluctuate, or their gender to continue fluctuating, at some point, if our situation is that of behavioral resonance, it will stop, or he or she will stop identifying. And that's actually, I'm gonna leave the computation, all the math to you guys. I'm just giving you guys the intuition of what exactly these things are. in our context or in our lessons. So you guys heard me already about this, the damped motion. So next lesson we're going to be discussing damp behavior. So this time there's a force that stops or at least hinders the decision making of the femboy, like say bigotry or homophobia, or his family doesn't like him being gay. That's like an example. It's gonna be a bit negative. I suggest you guys approach that topic or that next lecture in a more mature way, rather than an extremist way. We're gonna look at it in a pacifist view, point of view, and yeah, we're just gonna be talking about um, behavior that slows down eventually until it settles, or maybe it's sort of it can be a positive thing, like the femboy settling down or not being erratic with his behavior. He's starting to become more, he's starting to mature and start to come to terms with what he wants, what he plans, rather than skipping back and forth. It's very messy. This time it's more peaceful. It's for the life of that femboy. So after that behavior, we're gonna talk about a femboy that acts like a pendulum. You know, attach a bolt to a string and then pull it and then watch it go back and forth. That's a pendulum. It looks like something like this. It's a pendulum, and it swings back and forth, back and forth. And so that's it for this video. Sorry for the long wait for these videos. I'm sort of busy nowadays, and summer is starting to approach for the school. I know you're probably for future viewers that are watching this after I upload the videos. You guys, it probably wouldn't make sense to you guys, even though and especially those who are watching um, when it's winter or when it's spring or autumn, not summer. The summer break for L.o.S.C is about to begin. It's gonna start mid-April, and because of that, I'm gonna stop recording for that time being and continue recording in June. And if we're lucky enough, you guys can see me in full view, although I'll be wearing a mask because of COVID and the pandemic. Um, Maybe you guys will get to see me lecture in full detail in a much bigger space with better materials to work with. Um, because that'll be the time we're in face-to-face classes would start, and so yeah, it's better to work with a live whiteboard, a big whiteboard, an official whiteboard. This is just a pane of glass. It'd be better to be working like that or with that stuff rather than just being here. And I'll have a cameraman, and it'll be pretty silent considering we'll be in a classroom. So yeah, that's the thing. I'm still working on the course syllabuses and trying to fix them. I'm a bit busy nowadays when it comes to other matters concerning personal uh, and my academic life. I'm not gonna divulge much about my actual academic life. I'm not an actual professor. I'm just a hobby mathematician who plans to integrate this stuff. All right, you guys know the drill. You guys already know me. Um, so yeah, been busy nowadays, so sorry if there's hasn't been much activity on the channel. Well, don't worry, I will be doing Femboy review once we reach 100 subs, and at the end or the last day for this school year, I'm gonna be doing a live stream. Not just here, but I think also on Femboy Mathematics, or mainly on Femboy Mathematics. At Femboy Mathematics, where I'm wearing, I don't know, something, femboy outfit. And you guys get to see me in my entirety. So yeah, look forward to that live stream. I don't know. Or maybe not, because there's a chance it might not happen, but yeah, let's for it later date. So anyways, this is it for this video, and see you guys in the next one.